Okay, let's go ahead and start looking at the review over the 3 pages. I believe we said that's page 20 in our binders. Oh no, 19, page 19. Okay, so first couple we are going to solve using graphing. I'm going to work out the even ones with you, and then you can work out the odd ones independently. So that puts me right at starting at 2. So whenever you graph, remember the first thing you want to do is put it into slope intercept form. Okay, slope intercept form. So this one is clearly not in slope intercept form, right? Because it needs to be solved for y. So what I need to do is I need to take my x plus 2y equals 6 and doctor it up a little bit. The first thing I notice I'm going to do is I'm going to subtract that x away from both sides, right? So I'm going to put positive 2y equals negative x plus 6, okay? We got to make sure that when we're moving things over to the other side, we know how to combine those properly. And then from there, I'm going to divide by 2. Okay, divide everything by 2. So those 2's go away, so I'm left with y equals, now I am going to write this as a fraction, okay, because I need to be able to identify my slope. So I want to write the coefficient as a fraction. So negative x is the same thing as saying negative 1x, right? So I'm going to say negative 1/2 x plus 3. This is just going to allow me to clearly see what my slope is. So the first equation is new and improved, written in slope-intercept form, so that we can do our work on it. So I'm going to go ahead and erase that. Okay. Now my second equation, that was one of those special ones that we got going on, where it would be a little difficult for us to rewrite it into slope-intercept form. So what I told you, what we do, and the reason it's hard for us to write this in slope-intercept form is that this line won't cross the y-intercept, okay? So it won't cross it anywhere. So it means x equals 4 is the line, the vertical line that goes through where x is 4, okay? So I'm gonna label my axes over here. I got an x over here, that's my x-axis, you see, yeah. And then that's my y-axis. And if you'd like to put a couple numbers in, okay, you can, it's not necessary, but sometimes it can help us find everything. All right, -1, -2, -3, okay? So I got a few of them in there. So my first equation, let's go ahead and graph that one. I have a positive 6 for my intercept, okay? So that means I'm gonna be at y equals a positive 6. So that's 1, 2, 3, 4, 5, 6, okay? That's where my positive y-intercept is gonna be, okay, at y equals 6. And then from there, I need to use my slope to find my next points. Now the slope tells me to go down 1 and to the right 2, okay? Down 1 and to the right 2. I don't know if you can see that. So my slope tells me to go down 1 and to the right 2. Now I also could decide though that I wanted to go up 1 and to the left 2, okay? So as long as one of them is negative, it's okay. So when we're graphing, I recommend, we only need 2 points, but since we're not a computer and we're not super exact, I'm gonna find a bunch of points. So I'm gonna go down 1 to the right 1, down 1 and to the right 2, sorry. Down 1 to the right 2, down 1 and to the right 2, okay? Maybe I'll find some going the other way too. Up 1 and to the left 2. See how that dot's gonna lie on the same line? Up 1 and to the left 2. So this is gonna allow me to be more precise, okay? Because we know that we need to be super precise. So it's nice with Alex because they'll be precise for you, but sometimes it's hard to navigate that little button. Okay, so I drew my first line. My second line, like I said, is right where x equals 4. So take a second to review those vertical and horizontal lines if you need to. But when x equals 4, it's a vertical line going through x equals 4, okay? So let's look, where are my 2 lines crossing? Right there, okay? That's my point. So how do I name that point? All right, what is that point? Well, x is 4, that's very clear. Y is 4 also. So you always put the x and then the 4. So I didn't finish my step. So what do we need to do? Put in slope-intercept form, graph, and then step 3, identify your solution. And here, my solution is 4, 4. Okay? All right, so you guys gotta do number 1. So if you guys need help with that, just let me know. Okay, here 3, 4, 5, and 6 all tell us to use the substitution method, okay? So the substitution method is an algebraic method that will allow us to combine, mesh together the 2 equations by using substitution. So the very first thing you need to make sure you do is solve one equation for one variable. Okay, now, sometimes you're gonna find out you don't need to do anything on this one. Sometimes they give it to you that way. But here I don't have any of my variables solved for. So I am going to choose which one I wanna solve for though, okay? And I'm gonna try and do this smart, okay? I wanna think smarter, not harder here. Work smarter, not harder. So I notice that this x has a coefficient of 1. That's gonna be the easiest one to solve for, okay? So let's go ahead and do that. I'm gonna take this guy right here, x minus 7y equals 21, and I'm gonna solve for x. So the only thing I have to do is add 7y to both sides. Okay, so we have x equals 21 plus 7y. All right, so step 2, substitute. Okay, substitute and solve. So once you substitute, you're going to be left with one equation with one variable, one equation, one variable. So I'm gonna take my x equals 21 plus 7y and plug it into my other equation where x is. So I'm gonna have 2x minus 14y equals negative 42. But instead of x, I'm gonna write it in terms of y. Okay, that's math language right there. I'm gonna take x and I'm gonna write it in terms of y. What do I mean? Well, I know that x is the same exact thing as saying 21 plus 7y. So I stated x, only using y's. 21 plus 7y. Okay, and then from there, we just need to solve. Since we have one equation, one variable, we solve. The first thing I notice that I can do is distribute that too. So I have 41 plus 14y minus 14y equals negative 42. Uh-oh, what's about to happen, guys? Check this out. Positive 14y minus 14y, those go away. What am I left with? 41 equals negative 42? Is that a true statement? No. What happened here, guys? We started to solve. When we were substituting, both of my variables ended up going away, and I was left with nonsense. What does that tell you about my system? It's inconsistent. It doesn't have a solution. These lines are parallel. So when I ask you what's the solution, none. You write a 0 with a cross through it or a line through it. Don't write just a 0 because that's not true. This is the symbol for no solution. You could also write NS, no solution, okay? So you always want to be careful when you're doing these. Sometimes this will happen and you're thinking, did I do something wrong? No, it's just the equations didn't have a solution, and that's okay. Okay, so let's go for number 6. Y equals negative 5, and 8x plus 5y equals negative 17. So first step, you always want to make sure one of your variables is solved for. In the previous example, we had to solve for that variable, but now I don't. Why? Because y is already solved for. And actually, this one's going to be really easy, okay? So what do? You plug this in for y, okay? You plug whatever it is in for y. So I have 8x plus 5y equals negative 17. But what's y? Y is negative 5. They practically handed this one to us, guys. This one was easy. 8x minus 25 equals negative 17. I'm gonna add 25 to both sides. So I get 8x, oops, 5, 8x equals 8. And then I divide each side by 8. X equals 1. Now normally I'd have to plug this back in to find out what y is, correct? But what is y, guys? They told you at the very beginning. Y equals negative 5. This solution, this one was easy. That was an easy one. I'm glad I worked it out. That was the hard one for you guys. I'm just joking. I didn't want anybody to be thrown by it being a little bit simpler. So that was the substitution method. You always want to make sure one of your variables is solved for, substitute it into the other equation, and that's how you end up meshing those equations together to have only one variable left. After you have one variable left, you solve for that variable, and then you're able to plug it in to find the second variable. But this time was a little bit easier. So let's move on to the elimination method. All right, so elimination method, we're still working with algebra, so we're going to somehow combine my two equations together, but we're gonna do it in a different way. What we're gonna do is either add the two equations together or subtract them from each other. And so ideally what we're looking for is to have one pair of variables have common coefficients, okay? So I'm looking at my x's, they got a 2 and an 8, those aren't the same. I'm looking at my y's, I got a positive 2 and a negative 2. Actually, that's more ideal. I would like them to be opposites as opposed to being the same sign, right? Because when I add them together, I want them to go away. So this is ready to go. All I have to do is add my equations together. Okay, so I have 2x plus 8x is 10x. 2y minus 2y goes away, and then I'm left with 50. All right, so that's what we meshed the two equations together. Now we have one equation with one variable, so I can solve, and I have x equals 5. All right, so just like in the substitution method, what do we do to be able to find out what the other variable is? What do we do to find out what y is? All we have to do is plug it back into either original equation. Maybe I'll pick the top one because it looks like the number might be a little bit smaller. So I'll have 2x, aka 25, plus 2 times y equals 28. So 2 times 5 is 10, plus 2y equals 28. Subtract the 10 from both sides. I get 2y equals 18. Divide by 2. I get y equals 9. Okay, so that's my solution. The 0.59 would be where these two lines would meet on the graph. If I plug 5 and 9 into both of those equations, the equations would be balanced. We say that this point satisfies the equation, or these coordinates satisfy the equation. So let's look at number 10. Okay, so with the elimination method, you do always want to make sure everything's lined up. I think I forgot to say that in the last example, but everything was lined up already nice and neat for us. So that's the same thing that's happening here. Now, I will need a little extra prep work though. If I'm looking at it, I got a 4 and a 7, those aren't going away. I got a 5 and a negative 3, those aren't going away. How can I manipulate these numbers using multiplication so that the coefficients become opposites of each other? Well, I just need to multiply, and what it looks like, I'm going to need to multiply both of the equations by the other coefficient. So it's easier just to show you than done. I am going to eliminate the y first, and the reason I'm going to do that is because I noticed that I already have a positive and a negative. I like having opposite signs, because a positive, positive 7 and a negative 7 go away. A positive 10 and a negative 10 go away. A positive 10 and a positive 10 don't go away. You gotta like change the signs. So since these signs are already nice how they are, I'm gonna do that. So what do I need to multiply my first equation by, and what do I need to multiply my second equation by? I wanna eliminate the x's, so I'm gonna multiply this one by 3 and this one by 5. And like I said, I like the way the signs are already. I like that this is a positive and this is a negative. So I'm not gonna multiply by any negative numbers over here, okay? If I would do a negative number over here, it would mess up those signs, okay? And I don't want it to. So I'm gonna distribute. Remember, be careful at this point. I always feel like my mistakes and mistakes that I find on work is made during this distributing process because we get a little carried away. We gotta do a lot of distributing. So take your time. I got 3 times 4x is 12x. 3 times 5x, 5y is positive 15y. And then 3 times 22 is 66. And then I have 5 times 7 is 35x minus 15y. I forgot my y, guys. See, I told you, mistakes all over the place. 5 times negative 32. I know it's going to be negative. I'm going to write that before I forget it. 5 times 3 is 15. So 5 times 30 is 150. And then 5 times 2 is 10. So 160. Okay. Now they're ready to be combined because my 15y, negative 15y go away. I got 12x plus 35x gives me 47x. Equals 66 minus 160 is going to give me 94. Okay, and then when I divide by 47, I end up getting x equals 2. Oh, hold on. Negative 94. Sorry, 66 minus 166 is negative 94. So this will be negative 2. Those dang negative signs, I'm telling you. Okay. How do I find the y? Plug it back into either one of those equations. It don't matter which one. I'm running out of room over here. You can still see. I'm going to pick the top one, 4x plus 5y equals 22. Okay. I got to plug in negative 2 here. So I have negative 8 plus 5y equals 22. Adding on both sides. 5y equals 30. Divide by 5. Y equals 6. All right. So that wraps up this page. I worked out all the even ones with you. Make sure you're working out the odd ones. If you have any questions, just let me know.